right, so this is the start of chapter 5, and day 1 is parallelograms. So our goal for today is I can identify the properties of a parallelogram. You can go ahead and pre-rate yourself on whether or not you know those properties. All right, so first we're going to start with the warm-up. It says find all the angles in the picture. Go ahead and pause your video and try doing that yourself. All right, this is from chapter 3, so you should have, actually, yes, it was chapter 3. So you should recall those types of angles that are congruent. So first off, we have vertical angles. That's 62 degrees. This is a linear pair. 180 minus 62 is 118 degrees. These are vertical angles, so this is also 118 degrees. Now, those aren't the only 4 angles that you can find because I was given parallel lines. We know that when we have parallel lines, we have alternate interior angles that are congruent. So this angle and this angle are congruent. So this angle is 62 degrees. These are also alternate interior angles, so those are both 118. And if you notice, we could have also used the fact that this corresponds to this and copied it down there. But either way, you can get all 7 of those angles. You were given 1, so 8 total. And there they are. Okay. We have another warm-up here. Go ahead and pause the video and try that one. All right, let's see how you did. It says, given the information in the diagram, prove that the 2 triangles must be congruent. All right, so let's see if they are. So in order for 2 triangles to be congruent, they have to be congruent by side, 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 angle, side, angle, angle, side, or angle, side, angle. So let's see what we have here. We know that this angle is congruent to this angle. They're both 61 degrees. So far I have 1 set of angles. Next, I notice that we have parallel lines right here, and we have a transversal right here. So now I see alternate interior angles. So I can say that this angle is 44 degrees. So if you look, I have another set of congruent angles. This 44 degree angle is congruent to this 44 degree angle. Now, I could say the third set of angles are congruent, but there is no angle proof of proving a triangle congruent. So I need a side somewhere. So let's see what I know. I see that these 2 triangles share a side. So now I can see that the 2 triangles are congruent. The reason the 2 triangles are congruent are because of angle, angle, side. Angle, angle, side. All right. So next it says the definitions of words that we need to know for this chapter. First one is a quadrilateral. A quadrilateral is any shape with 4 sides. A parallelogram is a quadrilateral because it has 4 sides, but it's a little bit more special. It's special because both pairs of opposite sides are parallel, hence the name. So a parallelogram is called a parallelogram because it has 2 pairs of parallel sides. The opposite sides are parallel. These 2 sides are parallel, and then these 2 sides are parallel. Parallelogram. All right, so our first example here says find all the missing angles in the parallelogram. So since it's a parallelogram, remember, I know that these 2 sides are parallel, and I know that these 2 sides are parallel because it's a parallelogram. All right, so let's find these angles. All right, so let's start with this one right here, and I just picked one at random. All right, so I see parallel lines right here. 1 parallel line, 2 parallel lines. And there is a transversal right here. So if you look at these 2 angles, this angle that's blank and this angle, those are both on the inside and they're on the same side. They're same side interior angles. Same side interior angles are supplementary. 180 minus 62 is 118 degrees. So I know that angle is 118 degrees. Now, if I go on and look at these 2 parallel lines cut by this transversal right here, I have another set of same side interior angles. This angle and this angle are same side interior angles. 180 minus 62 is still 118 degrees. Last but certainly not least, I can get my last angle, parallel lines, transversal. These 2 are same side interior angles. 180 minus 118 is 62 degrees. All right, so if you look, we have a special property here. What we can see on a parallelogram is that we know that opposite angles are the same. These two are the same, and these two are the same. And we can also see that angles next to each other are supplementary. These two are next to each other, they're supplementary. Next to each other, supplementary. Supplementary and supplementary. We'll write these down in just a moment. All right, next one, it says find all the missing angles in the parallelogram. So instead of doing the parallel lines and figuring them out again, let's just use what we've learned from the last problem. This is 109 degrees because opposite angles are congruent, and then the angles next to each other are supplementary. 180 minus 109 is 71 degrees. Opposite angles are congruent, 71 degrees. In a parallelogram, what's special about the angle measures? So I put 1, 2, 3, 4 in here so it's easier to say these angles are congruent, these angles are supplementary. So I'm going to say angle 1 is congruent to, and which angle is angle 1 congruent to? Angle 1 is congruent to angle 3. And angle 2 is congruent to angle, so angle 2 is congruent to angle 4. I also know that I have angles next to each other that are supplementary. So if two angles that are next to each other are supplementary, so for example, these two are supplementary. So I can say the measure of angle 2 plus the measure of angle 3 is equal to 180. I also know that these two angles are supplementary. So the measure of angle 3 plus the measure of angle 4 is equal to 180. These two are supplementary. The measure of angle 1 plus the measure of angle 4 is equal to 180. And finally, these two are supplementary. The measure of angle 2 plus the measure of angle 1 is equal to 180. All right, so that was a lot to write down, but it's easier just to think opposite angles are equal, opposite angles are congruent. Angles next to each other are, or their same side interior angles, you can look at also, are supplementary. All right, so let's consider this next parallelogram with a diagonal drawn in it. Find all the missing angles in this diagram. So it's still a parallelogram, so I know opposite angles are congruent, 73 degrees. All right, but now I have these two lines are parallel because it's a parallelogram. Here is a transversal. We know alternate interior angles are congruent. Alternate interior angles are congruent. So I know that this angle right here is 25 degrees also. What about the other two angles? So the other two angles, I'm going to zoom in here and I'm just going to look at this triangle right here. We know that all three angles in a triangle have to add to 180. So if I add, oopsies, I didn't mean to do that. If I add 25 plus 73, I get 98 degrees. But then I have to subtract that from 180. 180 minus 98 is 72 degrees. So now I know, sorry, that's 82 degrees. That's 82 degrees. So now I know those angles are 82 degrees. 82, 82. Another way of looking at it is that I know that this angle and this angle are supplementary. So I could have also done 180 minus 73, which is 107, and then I already used 25, and then I can get 82 degrees. All right, so let's move on to our properties of parallelograms, because we've said a lot about parallelograms, but we haven't put it down in words. So first off, by definition, opposite sides are parallel. So we can go ahead and just do that on one of these. Let's draw the opposite sides parallel. So this side's parallel to this side's parallel to this side. We also just learned that opposite angles are congruent. So we'll use this same parallelogram here. We'll say this angle is congruent to this angle, and then these two angles are congruent. Same side interior angles are angles next to each other. So like these two right here, these two right here, these two right here. Same side interior angles are supplementary. All right, one thing that we haven't brushed upon yet, but it is true, is that opposite sides are congruent. So we also know, let me change colors here so it's easier to see in the diagram. This side is congruent to this side, and this side is congruent to this side. So opposite sides are congruent. The last thing that we know that we haven't touched on yet either is that diagonals bisect each other. Diagonals bisect each other. So let's show what that means in this parallelogram. Diagonals aren't drawn yet, so let's draw diagonals. Go from one corner to the next. Go from one corner to the next. Now you have two diagonals drawn. They bisect each other. That means they cut each other in half. They're both like knives. So this piece is cut into two congruent pieces. And this piece is also cut into two congruent pieces. All right, so now what we're going to do is we're going to use this knowledge to find variables in a diagram. If you notice, some of them have lots going on. Sometimes they don't have a lot going on at all. Okay, so we are going to find any variable that we can. All right, so we'll start with this right here. Okay, so first thing I'm going to do is I'll do these sides first. I know opposite sides are congruent, so I know that this side's congruent to this side. So I look and I say, oh, I can solve for x now. So I'm going to do 2x minus 5 is equal to 13. Add 5 to both sides. 2x is equal to 18. Divide by 2. And we get x is 9. So I can add that to my list of things I need to find. X is 9. All right, I still know opposite sides are congruent. So I know this piece is congruent to this piece. All right, so I have 7u plus 2 is equal to, and there's nothing over here. So I don't have enough information to solve for u. Let's see if there's any more u's in the diagram. Nope, there isn't. So that means I am not able to solve for u. So I'm going to put not possible. All right, let's move on to the fact that the diagonals bisect each other. Then we'll move on to opposite angles and same side interior angles. We'll use all that. So diagonals bisect each other. So I know that this piece is congruent to this piece. Notice I'm using a different amount of tick marks. Don't want to use one tick mark because I already used it. That means I can solve for y because I know 8y plus 2 is equal to 18. I'm going to subtract 2 from both sides. 8y is equal to 16. Divide by 8, y is equal to 2. All right, so now we know y is 2. Well, diagonals bisect each other, so this piece, I'm going to use 4 tick marks, is congruent to this piece right here. But I say, okay, well, I can set 7z minus 6 equal to this, but that's blank. So let's see if there's any z's anywhere else. There aren't. So that means that I can't find z. Z is not possible. All right. Excuse me. All right. Last but not least, we have V and W. Yeah, V and W. All right. So if you look at where they're located in an angle, but they also have a transversal drawn. So I'm going to use the fact that I know alternate interior angles are congruent. I'm going to say angle W is congruent to this angle. So W is 25. And then I know this angle, angle V, is congruent to this angle, which is blank, so I don't know it. So this is not possible. All right, so I found everything that I could. All right, let's move on to the next one here. Given the parallelogram, find the value of any variables that you can. All right, so I'm going to look at the diagram here, and I see that I have to solve for x and y. There's one x and one y. So I'm just going to pick one that I can solve for first. So I'll pick x and say, how can I solve for x? So if I look here, I know that I have this angle, and opposite angles are congruent. So I can say that those two angles are equal to each other. I'm going to say this angle is equal to this angle. 5x plus 6 is equal to 116. And now I'm going to solve that. So I'm going to subtract 6 from both sides. 5x is equal to 110. And then divide both sides by 5. And I get x is equal to 22. So I'm going to add that over here. X is 22. Now I have to solve for y. There's more than one way to solve for y. I could say this is 116 here and then do 180 minus 116 and figure out what this is. But that seems like more work to me than just saying these two are same side interior angles. They're next to each other when there's parallel lines involved, so I know they're supplementary. So I'm going to do 8y plus 8 plus 116 equals 180. All right, the left-hand side I'm going to combine like terms. So I have 8y plus 124 is equal to 180. I'm going to subtract 124 from both sides. I have 8y is equal to 56. And then divide both sides by 8. And I get y is 7. And I can add that to my list right here. All right, so once again, if you didn't realize what I was saying before because I just said it out loud, you could say 180 minus 116. That's 4, that's 6, that's 64 degrees. So now I know this is equal to 64. If you solve that, subtract 8 from both sides, you get to that 8y equals 56, and you still get y is 7. So either way is fine. It doesn't matter to me which way you do it. All right. The next thing that we are going to do, and it's last but certainly not least, is we have two problems on parallelograms in the coordinate plane. So I want to know if the coordinates provided provide me with a parallelogram. Now there's graph paper off to the side, okay? I don't necessarily like using the graph paper, so I'm not going to use it, okay? There is graph paper on the test? I can't recall. But I don't use it. You can use it if you want. I'm just not going to. And if you look, the next one, I don't use it at all. Okay, so what I'm going to do is I'm going to scrap the graph paper, and I'm just going to do my work off to the side here. So it says the coordinates of the vertices of RSTV are R is 1, 1, S is 3, 6, T is 8, 8, and V is 6, 3. Determine if and why RSTV is a parallelogram. So what I'm going to do is I'm going to draw a four-sided figure that looks somewhat like a parallelogram. Okay, and it can look exactly like a parallelogram. Let's see if I can do a better job of this. Just go like this. Yep. And then I'm going to label RSTV. Now make sure if you start R here, you have to go in a circle. You can't go zigzag. So I can't put S here. It has to be next to R. So it could be here or it could be here. I'm going to go there and then T next and V. Okay. All right. So now what I'm going to do is I have to know if this is a parallelogram. So if this is a parallelogram, then I know that RS is going to be parallel to VT. So what I'm going to do is I'm going to find the slope of RS and I'm going to find the slope of VT. All right, so we're going to use the slope formula in order to do that. So for RS, I'm using R and S. So I'm going to call R x1, y1, and I'm going to call S x2, y2. And I'm going to find the slope of RS. So RS slope, y2, which is 6, minus y1, which is 1, over x2, which is 3, minus x1, which is 1. 6 minus 1 is 5. 3 minus 1 is 2. So 5 over 2. That's not simplifiable, so I'm going to leave it. Now I'm going to do VT. So I'm going to call, here's V, I'm going to erase that. Here's V, here's T. So I'm going to call T x1, y1, and V x2, y2. And you could call V x1, y1 and T x2, y2, but I'm just doing them in order from left to right. You're going to get the same answer. All right, so I have y2, which is 3, minus y1, which is 8, over x2, which is 6, minus x1, which is 8. So that's negative 5 over negative 2. This is simplifiable. A negative divided by a negative is a positive, so this becomes positive 5 over 2. So my first question is or are these two lines are parallel? Are these two lines parallel? Yes, they are. 5 over 2, 5 over 2. So these two lines are parallel. So far I have one set of parallel lines. Now I need to know if my next set of lines are parallel. So now I'm going to check to see if RV and ST are parallel. So I'm going to write down slope of RV and the slope of ST. All right, so we'll start with RV. So I'm going to erase what I labeled x1, y1. I'll do R, x1, y1, V, x2, y2. All right, so I have y2, which is 3, minus y1, which is 1, over x2, which is 6, minus x1, which is 1. That's 2 over 5, which is not simplifiable, so I'm just going to leave it as 2/5. All right, now I'm going to erase that, and I have ST. So I'm going to call this x1, y1, x2, y2. All right, y2, which is 8, minus y1, which is 6, over x2, which is 8, minus x1, which is 3. That's 2 over 5. So the question is, are these two lines parallel? 2/5 and 2/5, they sure are. So these two lines are parallel. So now we can answer the question, is this a parallelogram? The answer is yes. It also says why. Opposite sides are parallel. That's the abbreviation for parallel, so I'm going to use it. All right, let's try one more. The coordinates of A, B, C, D are so forth. Determine if it's a parallelogram. So I'm going to draw a parallelogram again. And I'm going to, oopsies, and I'm going to call it A, B, C, D. All right, so this is A, B, C, D. And the picture here is just to help me pick the side. So if you want to make it smaller, it does not need to be huge. This is something that you're just using to look at to say like, okay, which two sides am I picking? All right, so I'm going to check AB and DC first. So I'm going to do the slope of AB and the slope of DC. All right, AB, x1, y1, x2, y2. So I'm going to do 3 minus 1 over 3 minus 9. 3 minus 1 is 2. 3 minus 9 is -6. Is this fraction simplifiable? It is. First off, is it positive or negative? It's negative. Now I can simplify it. 2 goes into itself once. 2 goes into 6 3 times. So this is -1/3. Now I'm going to find the slope of DC, or CD, x1, y1, x2, y2. All right, so I'm going to get those other ones out of the way so I don't see them. 10 minus 12 over 12 minus 4. Minus 4. 12 minus 4. 10 minus 12 is -2. 12 minus 4 is 8. So this is negative. 2 goes into 2 once, 2 goes into 8 4 times. All right, so first question is, are these two sides parallel? No, they're not. So no, I can stop working right now. This is not a parallelogram because opposite sides are not parallel. The other sides might be, but not both pairs are not parallel. All right, you can go ahead. Did I say it? Yeah. You can go ahead and re-rate yourself on how you feel about parallelograms for today.